So this week's lab is going to be appendicular skeleton, and specifically just the upper limbs. So the shoulder and the arms. So before we dig into upper limbs, let's talk about the types of bones that are in our bodies. So you have long bones, short bones, flat bones, irregular bones, and sesamoid bones. So all bones fall into one of those categories based on their shape. So long bones are your long bones, your arms and your legs. Short bones are going to be like the bones in your hands or feet, really tiny. Flat bones are like your skull bones and your sternum. Irregular bones are anything that doesn't really fit like a general shape. So your hip bones, your vertebrae, those are all irregular. And then sesamoid bones are bones that grow under tendons. And you're not born with these bones. They grow later in life, and they're usually round or square. They grow over joints, typically, where tendons pass over bones, and it helps like with friction reduction. So your kneecap is a free-floating bone that's held down basically by your tendon that goes over it, by your patellar tendon. That's a sesamoid bone. So it wasn't there at birth. It grows later, and they usually grow for friction reduction. So to continue on last week's skeletal system, let's talk about the structure of long bones briefly. So long bones are going to be broken up into three parts of like the length. So there's the diaphysis, the epiphysis, and the metaphysis. So the epiphysis is like the ends of each end of the bone, the top and the bottom of the bone. Okay, the diaphysis is like the whole middle part, and the metaphysis is the part in between where it starts widening to go to the actual ends. So the long middle part is the diaphysis. Above that is the metaphysis, and then past the plate or the epiphyseal line, the growth plate becomes your epiphysis. That's the end of the bone. Then the bone has an end osteum and a periosteum. The end osteum is the inside of the bone, the main middle part of the bone, and the periosteum is the lining around the bone. So one goes over and one is the inside. So long bones also have marrow, and they have two types, yellow and red. The yellow marrow is found in the diaphysis part of the bone in the medullary canal. So the narrow center part of that bone holds yellow marrow. In the soft, spongy part of the bone up by the epiphysis is the red marrow. So soft, spongy has red, and in the middle of the hard, compact part of the bone is the yellow marrow, and it's in the canal. So the hard part of the bone is the compact bone. The soft ends are spongy. And then at the end of the bones, where they articulate with a joint, it's going to be coated in articular cartilage to reduce friction and allow it to move a lot smoother. So if you look at this image, both ends have this gray cartilage. That's the articular cartilage that is specifically there to help the bone articulate smoothly. So as we're talking about the appendicular skeleton, we're going to get a lot into the movement of joints. So in our arms, since we're talking about upper limbs, we have our shoulder, elbow, wrist joints. Okay, all these joints have things called ligaments, which are things that attach bone to bone. The function of ligaments is to prevent the joints from moving a direction they're not supposed to stabilize the joint and keep those bones aligned. So we're talking about our knee. The knee only bends one direction. It has ligaments all around it that keep it only bending that one direction. So when you take those ligaments away, or if those ligaments get injured or broken, like you tear them, then the knee has all this extra movement and should not have. So their job is to attach bone to bone and provide stability and guide the joint to move in the way it is intended to move. If the ligaments become overstretched, you can have a dislocation of the joint, so your shoulder can dislocate if the ligaments are stretched too much, or if you tear one, you could lose your movement and it can dislocate as well. So stability, keep the bones lined up, and keep it moving in the proper direction. We don't want the knee to move side to side. The ligaments keep it so it can only bend one direction. So the pectoral girdle. So this is what supports the arm and connects it to the axial skeleton. So the arm is part of the appendicular skeleton because it's an appendage. It attaches to the axial, or to the base or trunk of the body, by the pectoral girdle. So the pectoral girdle includes the clavicle, which is your collarbone, and the scapula, which is your shoulder blade. So the shoulder blade and the collarbone make the pectoral girdle. So when we're talking about the clavicle, there is an end that articulates or meets up with the sternum, and then the other end of it meets up with the scapula or the shoulder blade. So the end that meets with the sternum is called the sternoclavicular joint because it's sternum and clavicle, sternoclavicular. The other end that meets with the scapula meets with the part of the scapula called the acromion. So that is called the acromioclavicular joint. So acromion to clavicle, acromioclavicular. And those are the two joints in the pectoral girdle. So the clavicle and the scapula have very distinct landmarks and distinct parts. So the clavicle has three main parts. It has the acromial end, which is the distal end, the part that meets up with the acromion of the scapula, so the one furthest away from the midline. That's the flat end. And then it has the body, which is the middle main part. And then the sternal end is like a rounded nubbed end that butts up nicely to the sternum. So one end meets the sternum in the middle of the chest, and one end meets the shoulder blade or the scapula closer towards the end of the shoulder. The scapula or the shoulder blade has a couple processes on it. First, there's the acromion, and this is the very top highest part of the scapula, and that's the part that articulates with the clavicle to make the acromioclavicular joint. Okay, then you have the coracoid process, which is in front of that and a little bit lower. Okay, that is a ligament attachment area, but it's below the acromion and it sticks out towards the front more. There is the glenoid cavity, which is where the actual arm bone articulates into the shoulder joint. This area makes the glenohumeral joint. So the humerus goes into the glenoid cavity and it makes the glenohumeral joint. There's a scapular notch, which is a little dip down in the top of the scapula, right behind the coracoid process, or like to the side of the coracoid process. And then the spine is this ridge that runs across the back of the scapula. So the front of the scapula is smooth and the back has a ridge that runs horizontally across it. That's the spine. So that lets you know that you're looking at the back side of the scapula. It's like a landmark to know that that's the back side. So since the shoulder is a joint, it has ligaments that help it move and help it stabilize. So there are 5 main ligaments in the shoulder. Okay, and all the ligaments are named for the bones that they connect, or the parts of the bones that they connect. So if you can remember the bones, the names will give away where the ligaments go. So first we have the acromioclavicular ligament. This runs from the acromion of the shoulder blade to the clavicle. So acromion of scapula to clavicle, acromioclavicular ligament. Then we have the coracoacromial ligament. This attaches the acromion of the scapula to the coracoid process of the scapula. So it goes from scapula to scapula. It forms like the upper wall, like the top wall of the shoulder socket. And in this picture, it's the yellow one. So it goes from shoulder blade to shoulder blade, but different parts, the different notches. Then there's the coracoclavicular ligament. This goes from the coracoid process of the scapula to the clavicle. So that is going to be the green and the blue ones. So scapula to clavicle. And then there's the coracohumeral ligament. This goes from the coracoid process of the scapula to the humerus. So that's the purple one in this picture. And then there's this thing called the transverse humeral ligament, and that runs transverse or sideways across the front of the humerus. And it basically helps hold down and secure part of a tendon. So that's this little red one right here. The shoulder ligaments are very, very stretchy because the shoulder allows for the greatest movement of your joint. However, because all these ligaments are really loose and stretchy, the shoulder is very easily dislocated. It's the most common dislocated joint, and it's just because there's a lot of movement in it, it can easily pop out. The ligaments can easily just overstretch and it pops out. It can easily be popped back in, but it does hurt. So the clavicle and the scapula make up the actual pectoral girdle, but the part that goes into it is the humerus. This is the upper arm bone, or like the femur of your arm. It's the big bone at the top of the arm. The distinct parts of this that are important to know is there is a head. So the head of the humerus is the actual part of the humerus that goes into the shoulder. So this is the part that articulates with the glenoid cavity or the glenoid socket to make the actual shoulder joint. There is a deltoid tuberosity, which is in the middle of the humerus, and it's like a bump in the bone, and that allows for a muscle to attach at a tendon. So in the humerus, it is a deltoid tuberosity because the muscle that goes over your shoulder is your deltoid. So it's going to attach to the humerus at that point in the middle that is raised. Muscles can't really attach to smooth, flat bones. They'll just slip off. They like little lumps. So a tuberosity is a tendon attachment point. There is the glenohumeral joint, again, same as in the shoulder. So where the glenoid socket and the humerus meet is called the glenohumeral joint. The joints are named for the bones that they involve. There is the radial and the coronoid fossa. The radial fossa is on the radial side of the humerus. So that's going to be down by the elbow. There is a medial and lateral epicondyle. So the medial epicondyle is the notch on the inside of the elbow. So looking at your humerus, it's going to be the one that's closer to your midline. Okay, so on your right arm, it's going to be on the left side. On your left arm, it's going to be on the right side. And then the lateral epicondyle is the notch on the outside. So on the right arm, it's going to be the right side, left arm, left side. Medial and lateral, medial meaning midline, lateral meaning further away. There's the capitulum, which is down at the bottom, and the trochlea, which is also down at the bottom. These are notches that help it articulate with the ulna and radius. Okay, moving on to the lower arm or the forearm. So you have two main bones in your forearm. The arms and the legs are very similar in the fact that they have one upper bone and two lower bones. So in your arm, you have the radius and the ulna. Okay, and when you're looking at these bones, it's easy to distinguish the radius from the ulna because the radius has a rounded head. And the term radius means round, right? When we're talking about radius, you're thinking of circles and stuff. So the radius has a rounded head. So the radial head is at the top and it's rounded. The radius has a radial tuberosity, which is a tendon attachment point, and that's right below the head. In this picture, it's a circular notch. There is a styloid process, which is the pointed end, similar to the styloid process in your face on the side of where your jaw meets your temporal, the styloid process. There is an ulnar notch of the radius. So the ulnar notch is like this dipped out region of the radius that allows the ulna to sit nicely in it. So it is called the ulnar notch, but it is on the radius. Okay, and then also the ulna has a radial notch for the same thing. So there's a radial notch on the ulna, which is where the radius nicely sits in there. The top of the ulna that articulates with your elbow is called the olecranon. That's like the head of the ulna. There is a trochlear notch, which if you look at an ulna, it has like a C-shaped top that grasps on to the trochlea of the humerus and kind of like holds it into that joint. That's the trochlear notch. It's a C area that wraps around the humerus. There's an ulnar tuberosity, which is the same thing as all the other tuberosities. It's a notch where a tendon attaches, but it's the ulnar one, so it's on the ulna. The head of the ulna is at the bottom of the ulna and not the top. So the top of the ulna is the olecranon, where you would think the head should be, and at the bottom is the actual head. Okay, and that articulates with your wrist bones. Between the radius and the ulna, there's a big opening, but it's not just a hole. There is tissue and fiber in there and muscle, and that's called your interosseous membrane. So inter meaning between and osseous meaning bone. So this is in between the bone membrane. Okay, and then where the radius meets the humerus, it's called the radiohumeral or humeral radial joint. Humerus and radius together make that joint. So ligaments of the elbow. The elbow has way less than the shoulder. It only has 3. And they're named really easy. So you have the radial collateral and the ulnar collateral ligament. Collateral means on the side, and radial means of radius, and ulnar means of ulna. So running down each side of your arm, on the elbows, you have a ligament on either side that keeps the elbow from moving side to side. The one on the radial side, or your thumb side, is your radial collateral. And the one on the inside, or your pinky side, is your ulnar. And remember, when I'm telling you right and left, I'm talking about an anatomical position. So the palms are facing forward because our forearms twist and you can rotate and you can completely change the side that your thumb falls on. It can be on the radial side and then twist over, and now it's on the ulnar side. So remember, every time we're talking about this, we're dealing with anatomical position to make sure we have the right side of the arm. Okay, so radial ulnar, or the radial collateral ligament is on the thumb side in anatomical position, and the ulnar one is on the pinky side in anatomical position. Then you have this thing called the annular ligament, and this basically goes over the head of the radius and then over the ulna. It kind of just wraps right around the head and like goes across the elbow, transverse ways, like side to side. So moving on down, now we're to the wrist. So the wrist bones, there are 2 rows of 4 or 8 bones, and they have weird names, but there's an acronym that you can use to remember them. The acronym is Sally left the party to take Kathy home. So starting on the bottom row under the thumb, we start with S, and then we go across towards the pinky, and then we go back to the thumb side, up 1 row, and across towards the pinky. So in this picture, we're going to start at the red and go across to the yellow one, and then go back to the light pink and across over to the dark pink. So the S in Sally is for scaphoid, and then you have lunate, the triquetrum, the pisiform, the trapezium, the trapezoid, the capitate, and the hamate. And that's in the order of Sally left the party to take Kathy home. Between these bones are plain joints. It's just bones gliding on bones. There's not a lot of movement in your wrist, in the bones of your wrist. So where your wrist meets your radius and ulna, yes, you have movement. But in the actual wrist itself, there's not a whole lot of movement. It's bones sliding. And then where these bones meet your palm are saddle joints. So the palm bones kind of C-shape and saddle around the wrist bones really nicely. So our palm bones are called metacarpals. Okay, carpals meaning wrist, and meta is of the wrist and further past the wrist. These are your palm bones. And in this picture, it looks like you have really, really long fingers, but the yellow are your metacarpals, the purple are your wrist bones, the green, blue, and orange, red, whatever that color is, those are the actual fingers. So the yellow is palm, okay? They're not separated like our fingers. So your metacarpals are really easy. They are numbered 1 through 5, starting at your thumb. So you have metacarpal number 1, 2, 3, 4, 5. And they're right and left. So right metacarpal 1, that's your right thumb. Right metacarpal 2, that's your right index finger, but on the palm area. Okay, where these connect to the wrist bones, they are saddle joints. And where they connect to the further up, like towards your finger, to the phalange, those are condylar joints. So your knuckles are condylar joints. And then the last thing we have, moving further away, so more distal, are your phalanges. And phalanges are fingers or toes. So on the hands, they're going to be the fingers, obviously. So you have 3 types. You have proximal, intermediate, and distal. And all of your fingers, except for your thumb, has all 3. The thumb only has proximal and distal because it's much shorter. So your proximal is your first part of your fingers. So before your first knuckle, or after your first knuckle, before your second knuckle. That is your proximal. In between your second and third knuckle, that's your intermediate. And then your fingertip is your distal phalange. Your thumb only has the knuckle where it meets your palm, and then the 1 knuckle before the fingertip. So you have the proximal is the bottom part and the distal is the fingertip. These are numbered exactly the same as the metacarpal. It's just phalange 1, 2, 3, 4, 5, starting at your thumb. So your thumb would be, your right thumb would be right phalange 1, your right pinky would be right phalange 5. And then you could be more specific in the area by saying right distal phalange 5, or whatever part of the finger you're talking about. Okay, but these are your fingers, and they are broken up into 3 regions, but they're all called phalanges. It's just proximal, intermediate, and distal.